Hey guys, welcome back to the channel. The day has finally come. Oh my God, I am so excited. Look at all these beautiful parts. The Cayman project is about to resume full steam ahead. I am over here at Flat Six's Skunkworks location. Undisclosed, top secret location for research and classroom prep. We got Jake Raby obviously here with me, and he is going to talk about some of the things that he has done and the parts that are prepped for me and what we have in store coming up soon. All right, Jake, thanks. It's great to finally meet you in person. I feel like I've met you before just because we've had so many phone calls together. But enough of the 997. Let's move on to the 987. So tell me what we have here.
Well, this is Project Crazy Cayman. Now, there's been a lot of Projects Crazy Cayman, trust me, going all the way back to 2006 when the Cayman was a brand new thing. But this is Crazy Cayman. So it's crazy, but it's kind of normal. When you've done this crazy a lot, it's normal to us.
Yeah, for me, crazy, this is nothing. Should we start with the block and talk about what we did here? I know that I mailed it to Ellen Engineering, and that's the last time I've seen it.
Yeah, so as part of this M9Xperience, as we deem this what people call an engine kit program, this actually existed for a while, and we've done this a few times, but now we've actually got kits for all the M96 and M97 engines available. So you'll be able to see those popping up and propagating on the Ellen Engineering site and Flat 6 here in a few days. But this kit was kind of the one that we were using to get a lot of our photos and stuff from, so we waited till now to kind of I guess it's kind of like a grand reopening of the kit program.
Well, I'm glad to help you reopen it.
So when you look at this crankcase, there's a lot more work done to it than what it may appear. It has a unique color to it for a very good reason. It's had processes done that are not straightforward and are not a production line bit of work. It's got completely different sleeves than standard. The Nickel process is still the same. It's got my roughness averages, my valleys, my peaks, all the things that we're looking for from a surface finish perspective that works with my ring packs, and all this stuff has already got all the P's and Q's are done, all the T's are crossed, all the I's are dotted, and for you, there's no guesswork, and that's what this whole thing is about, is making sure that we're selling you an unassembled engine. And you'll see that we've even done final cleaning on a lot of this stuff. Quite
unassembled here, yes.
Yes, very unassembled, right down to gaskets and seals. And we've even labeled where a lot of these gaskets and seals go. We've installed some things, we've prepped things, we've cleaned things. We've got pistons and rods loaded. We'll go over that a little bit later. But the crankcase has got, like I said, different sleeves. We have retained our open deck. Some people are confused about what open and closed and semi-closed decks are. This is an open deck, which means this entire area is open for coolant exchange. We made a few modifications in the water jacket areas to help with that. With a lot of these bore sizes like this one, very well proven, been doing this particular bore size since probably 2008 at this point with this process. And excellent results. Over about 3,000 of these blocks have been processed in that amount of time. And with the open deck, we have ultimate heat removal. Basically, you got thermal exchange of coolant between the cylinder and the cylinder head, and it's unobstructed. So when you see some of these blocks that are closed deck, they're at least advertised that way, at the end of the day, they're really a semi-closed deck, and there is a difference there. Then that kind of impedes that a little bit. We do something that's a semi-closed deck on some of the builds, or we do it by order, but I tend to keep this open deck with very strong material in the Nickel process from LN, because these are not just what people would call a sleeve. This is a cylinder replacement. So all the parent material has been removed on both sides of the crankcase, both the water jacket side and then inside the crankcase as well. So all that parent material has been removed, and we've got things solidified in here with some gussets and things like that to help keep things straight at these larger bore sizes.
Gotcha. Yeah, so the first thing I noticed, the difference between this block and the one from the 997 that I got back from LN is that it is much darker. So that makes sense that it's not just dirty, it's
well, it's been through a couple of processes. It's actually also been through a cryogenic enhancement process. So we do that to help stress relieve things after some of these processes are done. So that basically means that it's been frozen.
Right.
And it's been frozen at a controlled temperature for a controlled amount of time. And I've been working with cryogenics with engines since 1998.
Gotcha.
So there are a lot of benefits with that.
Very cool. All right, so I noticed that we have a flat 6 plug here.
Yeah, so you can take that out of there.
All right, flat 6, beautiful and shiny.
Yeah, so the factory one of these is threaded, okay, and it kind of goes in this location. And because we've altered the rod length of this engine, it doesn't even use a Porsche rod length anymore. And we've altered the stroke of the engine, and we've also changed the compression height of the wrist pin. So those things all get in the mix of where the wrist pin is going to be while Aaron's assembling the engine. And some people will come up with other ways of doing this where you space the case apart and all that, and we've done all that over the years. At the end of the day, when you have the resources and you want to do the job the proper way, I refer to this as the Raby method, where we machine out those original threads, we make that hole a different shape, so the wrist pin installation tool, like my faultless tool or the factory tool, either one, can then be at the right location to install those bank 2 pistons that everybody hears nightmares about, right?
Yeah, I remember that. It was fun. I've done it once. Looking forward to doing it again. Yes.
You see, this is my patented faultless wrist pin installation tool. This one is what we call like the golden article. So this is our first one we keep in case we have to have this to measure and make new files for because files got lost. But basically this bolts to the front console and this tube is adjustable for depth. And then you can turn this handle to deploy your wrist pin clip, okay? So something like this can be used with this tool, or you can use the regular old factory tool and you slam it home like I do in my M9X engine assembly video.
Yeah, that's the option I took. It is kind of scary, but luckily it seems to have worked.
Yeah, you'd know it by now if you'd have goofed that up. So at the end of the day, yeah, when somebody sees this, and I'm going to educate the competition here again, basically this means that I've been here. And this means that something in this engine is seriously modified. In this case, it's a lot of things that are seriously modified.
So we want to talk about the crank.
So what you see here, this is the crankshaft carrier that you sent us. So we did, throw this in the sun and we changed the, we align honed this and removed a bit of material and straightened this crankshaft carrier out. It does have coated bearings. So when we originally did this, just like most of these engines, the bearing clearance was too tight. And that causes shear, causes a lot of problems. A lot of those starvation issues people talk about are exacerbated because the main bearing clearance is too tight, and that ends up leading to shear, and then it ends up leading to wear, and then you have a main bearing start to shed some material. That material goes to cylinder 6 usually, cylinder 3 maybe 1, maybe 4, whichever main started to go bad, because of course all the oil going to the rod bearings goes through the mains. So if you have a clearance too tight on a main, it generates some material, that goes to the rod bearing and wipes out the rod bearing. So people look at it like, oh, my engine spun a rod bearing. No, actually your engine had a failing main bearing that shed material and created collateral damage.
Right.
But people don't think that deep sometimes. But once they hear something like this, then they do start thinking a little deeper. But at the end of the day, we did set the clearances the way that I wanted them. The factory has never released dimensions about this. There's no specifications released from the factory. Empirical data and experience is what's created our own running clearances, and that's why your crankshaft carrier has been assembled. So the connecting rods for bank 2 are also put in position. We checked the bearing clearances and altered those when we did the work to the crank, polished the crank, and set everything the way we wanted it to be there. And then this is ready to be assembled. So basically you're ready to put your intermediate shaft and your other items from the subassembly on this, and then drop this in the crankcase. So you're not going to have to clean anything. All that's already been precision cleaned and ready to go. So you want to leave this thing in the bag.
That's why it's in a bag.
Yeah, leave it in the bag, sealed up until you're ready to work with it.
Okay.
And then assemble it, put it right back in a bag, and then keep this thing clean. Perfect. Cleanliness is next to godliness, as you can tell around here. So you got to keep it clean. You got to keep it a nice, well-organized work surface, and you got to be in the game. Yeah. Don't have your buddies over drinking beer. Don't have the radio blaring. You're in the game, man.
Yep, I remember that from last time. You lose focus for a little bit, you make mistakes.
So also, moving on, you see some material removed from the pressure plate here.
Oh, yeah.
This is a full new dynamic mass. So most of these Cayman flywheels are bad. Yours was horrible.
Yeah.
It was trashed. So this is a new dual mass. No, I do not use a single mass. You can look up a lot of the things I've said about that online. Don't need to say anything about it here. But when you make real horsepower and you have good throttle response, you don't need to reduce the mass by 17 pounds to make people think the car's fast.
Right.
So when you're making real horsepower, you can put this mass right back on there, keep the car the way it was supposed to be, keep things smooth, keep things reliable, and you ain't going to worry about triggering knock sensors or other things. So we did dynamically balance this entire assembly. You can see right here, these marks, they're stamped. So 20 years from now, you can see that that's still stamped, and then it's stamped here. So where you got the O's and the V's. Any engine I've built in the last 25 years has got O's and V's on it. So that's the way you can align that. So if you pull this back apart, then you can always put it back the way it was in a balancer. Right. This is the combination where the least amount of material will need to be removed to get the components balanced and tolerance.
Okay. Very nice.
LNFSI underdrive pulley, that was also part of the dynamically balanced assembly. That only goes on one way, so you don't have to worry about indexing that. This is the billet tensioner paddle here from LN. This is one of our first developments. I had one of these things snap in half from the factory. I never used a stock one again. So if you have things break and you continue using those things because you want to cut corners and be cheap, then you deserve to have a failure. That's not cheap, and nothing's cheap around here.
Yeah.
So these are Carrillo rods made for this combination. This is one of the things that took us a long time to get because they are not a Porsche-specific rod. These are your bank one pistons. So we've also laser etched everything. This is cylinder one. So I've actually set the running clearance between cylinder one's cylinder wall and the skirt here to exactly where I want it to be. So we avoid tolerance stack. And what that means is when you have too many components that have unknown dimensions and you start putting those together, then if everything's barely in spec, by the time you get all those things put together, it's out of spec.
Right. Yeah.
So ultimately, we assume nothing and quantify everything, which means I've got a precision measuring center, and I've got bore gauges that go into crazy amounts of resolution, and we're able to make sure that the cylinder to piston clearance is the same on every bore. So what that means is we have to have the pistons first before the block is honed, and then we put targets on each bore when it's in the hone, and then not just from the RA perspective and the RVK and all the surface finish stuff, but also for a finished bore dimension. And then we have to double check that. So when you're putting this together, you're going to look at all these parts, and you're going to put cylinder one with piston one. All the way through. So you can't goof it up unless you don't pay attention.
All right, very nice. And then we have the rings for them that are already done.
Yep, the rings are over here actually. So there's a couple of rings that you could end up goofing up if you weren't paying attention. So we basically removed that possibility, and dot indicates top. So we put a little dot on there.
Yep.
That goes toward the top. So the only thing I'll say is when you are assembling this, you just need to take a little bit of carburetor cleaner and just wipe that dot off. It's not the end of the world if you don't, but I would rather you remove that. That's for indexing purposes.
Okay.
But other than wiping that off with a little bit of carburetor cleaner or alcohol, these are completely cleaned. They're gapped. They've been light checked. They've had the ring tensions checked on the oil rings, and actually had the ring tension set on most of these because not all of them are right out of the box. So this is real engine building, not engine assembling. We're doing the building part, you're doing the assembling part.
Yeah, that's the part I can handle. I can't do the building.
Yeah, so that's the real difference between a program like this. And I'll say that I started doing engine kits like this that are fully prepared in 2002 for air-cooled cars.
Yeah.
And so we've leveraged all that experience about what people goofed up, what people need help with, what people don't have the special tools for. You don't want to go spend $800 on a ring gapping device to do it right. Now, can you buy one for $13 on Summit? Yes, you can. But is it going to get things squared up the way that the proper tool would? No, right? So you don't want to have to go through all that. So the idea is that we make things that are hard easy.
Right. Yep.
And then that way everything is easy.
I like easy.
And of course, you're going to have support as you're doing this. That comes with this M9Xperience. It's a true experience.
Yes.
And we'll be using Zoom for that. We'll be using some text messaging, whatever the case may be, when you start to put this thing together.
Yep.
So yeah, these are ready to go together. You can even see wrist pin 1. That's lasered wrist pin number 1. That matches with piston number 1. And that matches with rod number 1.
Wow.
Which I don't know if you can even see it on here. See rod number 1 right there.
Wow.
So we assembled it all, but even if you had to take that back apart, you can put it back together again. Or 20 years from now or whatever, when you're ready to build it again, or if you need to freshen it up because you're going to track it a lot, then you can take all this apart and it's already indexed.
Yeah.
You can put it right back together again.
That's amazing.
And people look at it and they're like, well, that's overkill. No such thing as overkill when you're as crazy as I am.
Nothing too crazy for the crazy Cayman. All right.
So just got some random gaskets and stuff. New timing chains. These were also cryogenically enhanced. So that's something that we've learned to do with the timing chains. I've been doing it for a long time. It really seems to help them. That's not just a freezing process, but it's a full thermal cycle. Things like heat exchangers new. You never trust these because they get debris in them. That's been ultrasonically cleaned and pressure tested. Okay. So it's not, there's no guesswork there, no question marks.
Nice.
This is some of your pieces for your deep sump. You'll see that in there. So that's got all the cool stuff with the deep sump. There's pieces I didn't want you to be able to lose out of the boxes. So that is one of the billet deep sumps. Of course, everybody will see that at home.
Sure.
But this is what it takes to basically, we base this off of a stage 2 engine. So it's got all the tricks and things that a stage 2 would have.
Yes.
If you built it, bought it from flat 6. Obviously.
Okay.
New timing chain rails. They're labeled, as you can see, upper and lower. Even though you can figure that out by using the Porsche Pet, we make it where you don't have to. We already put what it is, right? Again, you don't want to guess. Even gave you a new oil level sender because they have updated those, and they will give you a little bit better resolution for level, and they will also give you a little better resolution and real temperature for the oil temperature. People don't realize that. Same thing with the coolant temperature sensors. We kind of learned those things the hard way over the years. When you see what temperatures are before and after, and all you did was change a sensor. Cylinder heads, obviously one of the biggest parts. These are the intake ports. These are the exhaust ports. We set you up at about 13.3 to 1 compression, which is a little conservative for this combination, to be quite honest, because I'm not building it, and I'm not going to be the guy that's driving it, and I'm not going to be the guy that's doing a lot of the stuff with it. So I didn't go crazy with super tight deck heights and things like that. We've got the deck heights where everything is very safe.
Okay.
It's not anywhere on the edge. Could I go higher with that, even on pump gas? Absolutely. We put these engines at 14 to 1 on pump gas. But when we do that, you have to have what I call the Raby advanced timing system. So we're able to go in and not use the factory tools to set the cam timing. You use my tools, and you do that a completely different way. And then you can dial the cams in, and you can change the lobe separations, and you can change the way the engine reacts to the stock camshafts.
Oh, wow. And
you can effectively make the engine think it has bigger cams by using the stock ones. In your case, we're not going to do that because that is difficult.
Sure.
But here, you'll still be able to use your factory cam timing tools just like you did with a 997. Okay. And everything is very safe. Piston to valve clearances, obviously, we've been checked with these pistons and all that sort of thing.
Great.
Of course, we've got a lot of valve work done, all new seats, all new guides. We never trust these valve seats. Cayman heads, these M9/721 heads and the M9/605 heads, a lot of times have the worst valve seat problems. They will literally fall out of the cylinder heads. I put these heads upside down in my ultrasonic machine and had 2 or 3 valve seats fall out in the ultrasonic machine just under heat and a little bit of vibration from the ultrasonic. And we've seen them fall out in operation and cause a massive failure. So we assume nothing and quantify everything with that. All new seats, all new guides, all new isotropically surface finished valve springs. So you guys will see they're super shiny. That's not for looks. That helps with the fracture proofness part of things, right?
Okay.
We're removing stress risers from it. So and those have also been cryogenically enhanced. And a lot of guys that don't want to do cryo work, they don't want to send things out, they don't want to process things. They say that stuff's not required. Well, maybe at their level it's not, but it is at mine.
Yeah. So
these are custom head gaskets. So these are made especially for this bore size. These head gaskets are not cheap because what we do with this combination, it requires a little different bore size than what you would normally be able to have. So with that, we had to have special head gaskets made. And see, Snowflake is joining us here. So she's up here trying to get some of the parts dirty. Luckily, they're all
Come on
bound.
through. Yeah, you can't get to them.
So yeah.
And what is the bore size?
102 plus, so it's a little bit bigger than 102. And like people are saying, oh, how big is it? Well, if Porsche was advertising this, they would call it a 4.2. You know, that's just the way that they round things up. I don't know if something gets lost in the SAE conversion, right? But we call it a 4.1 because it should be a 4.1. It's not quite 4150.
So I'll put a 4.15 on my.
Yeah, it's there. 4.1 plus is what we'll call it. We can take this bigger. I mean, obviously, if I go bigger with a crank stroke, you know, factory is the longest you can get 82.8. You know, this with strokers, I start around 88 millimeters and go to 89, 90, 91 millimeters with some of the big R44s and stuff like that. That's one reason we have that machined provision in the case, is because engines get really difficult to build that way unless you start using spacers and doing all the hokey stuff, which you can do. But we have the ability to go up to a 105 bore, and at this point we've gone to a 91 millimeter stroke.
Okay.
Not every time, because it's expensive to do that.
Yes, it is.
Random stuff in here. You even have a lot of new hardware. So you've got new case bolts. I mean, this is everything, guys. These are new factory case bolts, and I see people cutting corners and just putting, they're putting sealing on stuff, and I've done that before. But, you know, why are you going to cut corners on bolts?
Yeah.
Right? I mean, only a fool cuts a corner on hardware.
Yeah.
You know? That doesn't make any sense to me. If you're worried about budgets, you have the wrong car. So we clean things like the screens that go inside your heads. You know, all that's been ultrasonically cleaned. And those were dirty, by the way. They always are. So we go through and ultrasonically clean those. Just some random stuff in here. New crank position sensor. I mean, this is super comprehensive, man. When you get home, you're going to be like, wow, even knock sensors. You know, I mean, everything is here. We left nothing to spare.
Beautiful.
So, of course, everybody is like, oh, how about the IMS? How about the IMS? Well, this shaft has gone to LN Engineering, and it's been pinned. And the reason why this is pinned is because there are times where this rear sprocket will actually separate. I call this motor failure 24. And what people don't realize, if you zoom back out here, an intermediate shaft is comprised of 4 pieces. You have this driven end, okay? And then you have the tube. And then you have another end, which basically this drives your bank 2 cams, right? This drives your bank 1 cams.
Yep.
So this is a piece, this is a piece, this is a piece, and then this is a piece. So we've actually had this hub fall off. I'll show you guys one downstairs. And that's the reason why these are pinned in place now. So that can't come off.
Okay.
Again, you got to keep in mind, this was made by the lowest bidder, even though it was a Porsche part. This was the lowest bidder part.
Gotcha. So this end never falls off.
No, these are super swedged on. I've never seen one of these move, ever.
Okay.
Not to say it can't happen, but I mean, when I've cut these shafts apart to make tools and to do things, I mean, this one, it's a bear to get this off here. It's a real bear. You almost have to cut and then torch things. It's a real bear. And the same thing here. This is swedged on good. This has got very little engagement onto the tube, because the tube protrudes all the way through this hub here. It goes back to this point. And then that sprocket, literally from the factory, is on there with a hope and a prayer. So when this goes to LN, it's not just pinned and it's not just, you know, modified in that way. We've also installed the IMS solution for you. So the bushing is installed. Now, if you just send your shaft to LN, it's not part of this kit, you're not going to get this service, obviously. But everything's already here, so you can't goof that up. Because, you know, if you install the bushing incorrectly, beat it in with a hammer, actually in the Neanderthal, whatever, you could possibly screw it up. So we've eliminated that, and this is the solution flange, and it's in place, ready to rock and roll.
The less they can mess up, the better.
And then here, the other thing that we do is this goes into a special fixture, and the run out is measured on the tube and also at several key points on the root and the tip of each of these sprocket cogs. And that's so we can check for run out. And back here, we also check for run out. So there is a time where we've seen intermediate shafts kill their bearings. because the factory put this together and it was elliptical, it was wobbling. And if this rear section that holds a bearing is wobbling with a ball bearing or anything other than a solution, it is going to kill that bearing. It has no choice but to die. So that's why I've seen people have several bearing failures before, because a shaft was bad and it was never caught. So we've seen these as much as 20 thousandths. That's half a millimeter out. So this one I think was 3 thousandths out, which is damn near perfect. It's about as tight as you can get one.
Okay.
So there's a whole stack of these that check bad and they look perfect.
So it's not just the manufacturing of the bearing that causes IMS failure. A lot of times it's the run out of this.
Well, the thing is, if you put a ball bearing in there, it's a precision ball bearing that's already kind of underrated for the load carrying capacity. And of course, this had the big bearing in it, which is overkill. The big bearings are great in a lot of cases, but they're still a ball bearing. They still have all those wear pieces. With the IMS solution, you have no wear parts. It's basically controlled both radially and longitudinally thrust-wise from a film of pressurized oil. So every time you change your oil, you're changing your IMS bearing.
Nice.
So this might be a cool time to show them some stuff over here. Archives.
Yeah, let's come over here
That's
to
why I
the
call this
archives.
Skunkworks. I got all my cool stuff over here. So this was IMS product number 1. Try to get some better light on it here. So this was our very first go at making anything for an IMS bearing. So this was made on old Bridgeport machines. This center stud's actually out of a Caterpillar bulldozer. It's modified. This one's got like 14,000 track miles on it, and it never failed. But this is a quad row bearing. So with these, we had to machine the inside of the shaft. But this is a bearing, this is a bearing, this is a bearing, and this is a bearing. So, you know, even though I don't believe in overkill, this is kind of overkill, right? But this was made on old manual machines. This is numero uno, the real thing. You guys held the history maker in your hands.
That's awesome.
And so this is IMS solution numero uno, and it actually failed after 32 hours. It looks nothing like the production model. It took 5 generations to get it to where it's at, where it's been since 2010. This is Ampco 45. The first and last time I listened to a metallurgist was this, and that's what made it fail. So we changed everything about the design except for this diameter. We actually took this diameter from the Metzger air-cooled engine and maintained that diameter all the way from the very beginning until the end. We tried different diameters. They didn't work as good. Porsche did the math on this.
Yeah, they got that one right, huh?
Yeah, it's actually the same as the camshaft diameter on a 356 on the main bearing, on the main cam saddles.
The magic number.
Yeah, so, but yeah, this was just started out life as regular old parts. There was none of this heat treated, you know. And it was the very first effort, and that, like I said, failed at 32 hours.
Very cool.
And that's the only time we've had one of these actually fail in testing. This was probably version 4. This is what we were doing before we were doing the DLC coding. This is a WPC coding, and we actually have some versions that use this still and not use the DLC. So we got those, and I kind of showed you the faultless tool already. We can go over and I'll show you guys the shaft that came out of that very first engine. So this shaft, IMS shaft, came out of that very first failure. So that's the shaft that failed. So you see here how the front console kind of welded itself on. It's because at the rear it lost control. The thing I'll say, this engine still ran. And it had no symptoms of having anything wrong with it.
Oh my gosh.
And we actually learned that we had a fail-safe built into the solution, because if it tried to seize, it would allow the engine to continue running. So I did not even know it had failed until I pulled it apart. And this actually fused on here when we shut the engine down.
Wow.
Because after we shut the engine down and it cooled off, we couldn't turn it anymore. And this is the reason why. And it basically broke off the front console. And this is the bearing that had been pulled out of that engine as an original 6204 single row.
And now we have a super cool lamp.
Yeah.
All right, so time to load all of this stuff up into the car. So I guess the next video that we're gonna see is, I'm gonna work on the crankcase carrier first, I guess, right? Step number 1.
Yeah, so I think the key is, obviously you can follow my M9X engine assembly video series, you know, that 20 hours, you know, basically it's 20 steps, 15 hours of content. I actually filmed that in this room.
Yes.
140 hours of video was collected in this room on 6 cameras to do that. Actually, that's still the boom that we used. But ultimately, since we've already done a lot of the assembly of the carrier, what you're going to do is you're going to finish the sub-assemblies onto the carrier. You're going to, you know, add in the windage tray, and you're going to put the intermediate shaft on it. You're going to put the IMS drive chain on. You're going to put the billet tensioner paddle on. And then once this is built up, we're going to do some quality control on that work. Make sure it's good, because you've got to check your work when you're done. You assume nothing and quantify everything. So after that's done, then you're going to go and just wipe down your cylinder bores, because they're going to get a little bit of dust in them. There's no way around that. You're going to wipe them down, blow everything dry, and you're going to start being very careful about keeping things clean, keeping your hands clean, keeping the environment clean, keeping your cat out so she doesn't go downstairs, and things like that. And then we're going to integrate the carrier into the case.
Yep.
And then we're going to assemble the Bank 2 crankcase half. And then we're going to put in the Bank 2 pistons. And then you're just going to do it basically in about 6 major steps.
Okay.
And before you know it, you're going to be done. And what we do, you don't look at this like you're building a whole engine. That's the wrong thing to do, right? Just like when I'm wiring a car, I don't worry about the bundle of wires that's the size of my wrist. I worry about the one red wire with a black trace on it that I've got to connect to a certain point. I worry about that wire. And then once that wire is connected, I check my work and I go to the next one. And before you know it, you're done. So with this, small steps, get confidence, check your work, go to the next thing. Before you know it, instead of having a bunch of pieces on the table, you have an engine.
All right, so let me ask you this. So for those out there watching who have a similar car, an M9X of some sort, what should they do if they want to do something like this? Reach out.
If they want to have a really well thought out, well executed, you know, support based type of program where there's not question marks. You don't need another machine shop. You don't need anything from anybody between what I do here on site at Flat 6, what we do with our partners Ellen Engineering in Illinois. There's nothing that you need other than this. You buy this and you're done.
Okay.
And then it's just a matter of you putting your time into it, you listening to my support. Usually what we're doing with these is, and what I've done in the past, is we'll get 2 or 3 guys that have a similar build, and we'll say, okay guys, we're going to process your stuff together, and then hopefully you can build it together, and that way we have support groups.
Yep.
Because the assembly is basically the same with all these engines. It's just in that way, instead of me sitting here helping one guy at a time, we have a support group. There's actually a Facebook support group for this. So
yeah, hopefully I will be involved in that, and hopefully these videos that we're creating are also a helpful guide for those guys, so they can just reach out to you straight through the website.
Yeah, the best way to do it, since this is a collaborative effort between Flat 6 Innovations and Ellen Engineering, as you can kind of see behind me here. We merged things technically together back in 2022 after working together since 1998. Basically, you would submit a ticket at flat6innovations.com, and that kind of starts things. And from there, then you'll be put in touch with the right person at Ellen Engineering, and we will start configuring a kit for you. So again, it's not just a pile of parts, as you can see. You do get a lot of parts, but you also get a hell of a lot of priceless support. Yes. And you get the experience that, you know, let's just put it this way. The guy that's helping you didn't start building engines last year.
All right, awesome. Thanks, Jake. So this should take me like 4 hours to assemble, right? Is that what I'm...
Well, and if you're pushed, you can do 2 in a day.
All the parts are safely back in North Carolina, and we are ready to start the assembly process. I got parts all over the place. All of those are Crazy Cayman parts. So let it commence. As always, thank you for watching, guys. Hope you give this video a thumbs up. Hope you're subscribed and follow along if you would like for the Crazy Cayman build. If you guys want to check out my Facebook page, I have a Help Me DIY Facebook page and Instagram also as well. So feel free to follow along. If you happen to be building one of these at the same time, that'd be cool. Get a hold of me through the Facebook page. Feel free to ask questions, post your videos, your pictures, whatever it is, and let's build an engine.